Random thing, does anyone know what the keyboard shortcut for the next slide is? So, what are we going to do today? Why I've been doing all this, how I've been doing it, and the results, of course. The why is easy. At some point, a friend and me started reverse engineering one of our Berlin car-sharing operators, just because we wanted to see how their systems are built. You know, software engineering students were kind of weird. But then we realized, just like you, we are just nerds who are interested in sustainable solutions to urban mobility. And so we started collecting data to just see what we could do with this. And we figured that while many vehicles are used within 30 minutes after they've been last used, like after the last trip stopped, roughly half of them are just idle for 3 or more hours. And that kind of goes against the whole point of car sharing, right? We're trying to use vehicles as much as we can to not have empty metal standing around in the city. And the operator of this car sharing obviously already does some relocations, moving vehicles from places where they aren't used to places where they should be used or where people want to use them. So without that, this would look even worse. But all of this comes at a cost. In Munich, apparently, one single relocation takes around 27 minutes, including getting to the car and then driving it somewhere else. In Berlin, of course, is a bit larger. So this probably costs the operator around 10 euros based on income, like salary for the driver and prices of the car and everything. So there must be a better solution. And the solution that I thought of was, what if you incentivize users who use your system anyway to take cars to a place where they're needed more, but kind of without hassling them? Because one of the main points of car sharing is that it's just easy to use. One researcher found that he could achieve a 22.5% increase in revenue because of increasing the fleet balance throughout the city by using different measures, dynamic pricing, combinatorial charges. And I wanted to see if I could maybe show an opportunity to get to this number without charging people more. So, again, software engineers, of course, I built this super modular, partially distributed scraping service in TypeScript. And because we're not accessing the data directly, but we're kind of just scraping them from the service, there's a small delay in when a trip actually starts and when we detect the trip starting, because we don't really want to like DOS the service and just take it down. So there's roughly a 1 to 2 minute delay. I think that's quite reasonable. And then we also collected a bunch of POIs, so just locations, interesting locations on the map, like restaurants, schools, whatever. And traffic data and weather data, just to see if they have any influence at all in how people use car sharing. Then I clustered all of this in a H3. It's not a grid. It's a hexagonal grid kind of thing, developed by Uber, really useful for spatial indexing, and just stored it in a Postgres database for later use in my beautiful notebooks. And also, if you haven't heard of Influx, it's pretty cool. It's a time series database that is really good for observing stuff. So in total, I collected a bit more than 1 million trips for 6.5 grand cars, 40,000 interests on the locations on the map. And there is no real publicly available data set on car sharing. So compared to nothing, this is quite large, but also compared to what is currently mostly being used in research, like the GeoLive dataset from Microsoft. This is much larger. But if you're interested, there are incredibly huge datasets on ride-hailing, ride-sharing bikes. For example, City Bike, they have like 3 billion records. You should look into it. Yeah, privacy. If you're scraping data from this provider, fortunately, there is no user data anywhere in this API for public use or semi-public use. But you can probably do some shady shit with it, like when you identify someone sitting in a car and you know the license plate that they're using, you can go back in time and see where they came from, and you can also just live track them and see where they're going. That's bad. But of course, it's a car sharing service, right? You have to tell people where your cars are, so you have to expose some data, but maybe implement basic security. There are other car sharing providers that do much better jobs at this. So first I wanted to see, can you predict demand for cars based on just like contextual factors, stuff around you? And there's this quote that I found, car sharing is a complex business and humans can anticipate certain effects before they are reflected in the data. That's very true. That's why it's complicated to like anticipate demand in real time, but let's try nonetheless. And obviously there is more demand or more trips in the city center, so we have to account for this. A really good method is to just residualize against the total number of trips in this specific location, in this hexagon, for this type of day or type of hour. And then we can run a Getis-Ord Gi analysis, which basically finds clusters of hot and cold areas. So red means there are more trips in this area at this time. So example, midday on weekdays in Mitte, than we would expect. So something's up here. And blue, just the opposite. There are less trips than we would expect. Very easy to implement this using PyData. Fantastic library. And then another fantastic method is GWR, geographically weighted regressions, which is basically just a regression, but on every single spatial class there is. And here we're not looking for clusters specifically, but we're looking for the local influence that each in this case, POI class, POI category, has on trip demand. This obviously lets us see how this changes throughout the city, and there's a fantastic package for it, MGWR. And yeah, so the result of this is, in my research, it's actually quite useful for explaining. Like in my data, just POIs can explain almost 50% of differences in trips, like more or less than we would expect on weekdays. On weekends, it's a bit more complicated. And then, for example, in the early morning, on weekdays, education has a really strong positive impact, so that might suggest that residential areas that have more schools and less other less other POIs, people use cars in the morning more, and then by midday, education has a negative effect, but accommodation like hotels, hostels, and culture, like museums, have a positive impact. Also found this one is really interesting, which is just running the same GWR on transit POIs, so like mostly train stations. And you can see, especially on weekdays, which is the left animation, the demand, there's like a really stark contrast in positive and negative demand, and it just moves throughout the city during the day. There is some co-location between different POIs categories, which is something that I should have looked into before doing all this, but I didn't. I did it afterwards. So there is some opportunity for improvements if you actually look at what kind of things you need. For example, food and drink locations are somewhat closely co-located, maybe intuitive, but yeah. You can also see using a different method, which is the bivariate local Morans, in which areas of the city this co-location is the strongest or the weakest. So you can see here the different colors are either high concentrations in both of the categories, low concentrations, or high and low, which is the orange and light blue. So you can see that there is a strong co-location of food and drink categories in some areas of the city, but in others it's not as strong. Also, PyData can do it all for you. I said I wanted to look into the weather and traffic impacts. They are statistically relevant, practically. They account for like less than 1% of trip differences, so we're just gonna skip over that. And then I also wanted to see if you can predict where people are going. Now, the difficult thing here is I wanted to predict where people are going before they even went anywhere, before they even know where they were going, maybe. And you might ask, why? So there are a few different solutions to this vehicle imbalance problem throughout the city and how to solve them. For example, many micromobility services like Nextbike or Bolt scooters have these bonus zones. Like you just go to this zone and you get €3 reward. But this may not always align with user intentions. For cars, these zones would have to be quite large and far apart for them to make sense. And if you don't want to go to the zone, then I don't know, it's weird. And it also just feels cheap somehow. I spoke to a friend, and he was like, no, it doesn't feel cheap at all. And then I was like, well, why do you like it? And he's like, well, because I'm cheap. So next possible solution is what another service provider in Cologne used at some point. Zone-based pricing, so if you go further out, you have to pay more, which kind of incentivizes people to stay in the zone. But that can be really complex for users to understand, especially if you have multiple zones. Like one is like 20 cents more expensive, the other one is 30, and everyone says like, what's happening here? And then the third one, it is much easier to estimate where someone is going if they already started going there. And there's really good literature on this. They get like 80% plus accuracy after users completed 50% of their trips. And maybe I thought, it motivates people to take cars more often, like car sharing cars more often, because they hope getting a discount. But like that kind of defeats the whole point of moving cars away from low demand areas. And yeah, it is human mobility prediction is a really well-researched topic. And apparently you can get 70 to 95% accuracy if you know the last 2 locations that someone went to. But because of the good privacy thing, that we don't have any user identifiers, we also don't know the last 2 locations. That's kind of boring, that's kind of annoying, but let's see what we do have. On a holistic view, on the left side is the average distance that people travel using car-sharing cars. On the right side is the median direction. You can see there's a clear east and west split, but a slight southwards direction. Then the most common trips are obviously within districts, which makes sense if you look at how short most of the trips are. But there is also a strong connection between Wilmersdorf and Mitte and Friedrichshain. So people like to drive between those districts. And to solve the prediction problem, I tried 3 different models because I found them to be most popular in what other people have done. There's a logit model that I applied, a cat boost, and a GRU. So these obviously keep going up with complexity. And the first one, the logistic regression, did outperform just taking the most common destination for a given departure time and location and everything. But you can see it's like 9%, not even, for picking the top 1 destination location and 22 for picking the top 3. So is it worth it? Probably not, but it's easy to implement using scikit. The next one I tried, cat boost, categorical gradient boosting decision tree, which is a gradient boosting decision tree that works on categories, is also easy to implement at first, but it's kind of annoying to tweak, and it did not even outperform the logit model. But if you want to use it, cat boost, great package. And then the last one, mostly in the research I saw, they're using LSTMs, but I used GRU because it's quicker and because on short sequences, it often outperforms LSTM. And then I added an attention layer, which basically helps the model memorize what it's doing instead of just using the last output always. And this one did outperform the logit model, but obviously that's still nowhere clear usable in production. That's kind of sad. But also, this one can be implemented using PyTorch. So it's kind of disappointing. The dog is sad. But there is hope. There is hope. Because I said human mobility is well researched, right? So Song and her group found that 93% of human mobility outside of car sharing, like general mobility, can be predicted just based on your history. That's kind of scary. I don't want to be this predictable, but it is what it is. And then I applied her same calculations and theory to my own data set, because, as I said, car sharing is just a subset of human mobility, and the theoretical maximum that we could achieve if we just added a user identifier to our current data set is almost 45%, which may make sense for operators to trust in those 45% and try to save some money on drivers that they employ to relocate vehicles. And that's all. Now I want to see if you have any thoughts on urban mobility, car sharing, and scraping their data and analyzing it. If you do, please raise your hand.
Any thoughts? Also, you can share them on the Slido, but no question so far. Who wants to have the first? Yes.
Could you distinguish the, like, for some car sharings, there's this option to take this car, we will pay you €3 if you drive it away from the current location. Could you distinguish that in any way, or could you?
Yeah, so at least from the providers that I researched, this method that you're saying is usually just based on, oh, this car has been standing here for 4 or 6 hours, so we're just going to discount it, because we think if it's been here for a long while, it's probably in an area with low demand. And what I'm trying to do is see if the area that it's in currently is probably low demand in very close future, and there are other areas that are high demand but don't have enough vehicles.
Thank you for the talk. I wanted to ask if there is any data sets on driving behavior, and if you could compare from the data that you have driving behavior between people who own cars and people who ride these cars.
Thank you. That is, yeah, it's definitely very exciting. And there are data sets on private vehicles too, also large data sets. I did not compare them. But if you would like me to share this data set with you, and then you can access the private car one and look at it yourself, please. And also let me know of the results.
Very quick question. Can you maybe add a few words about the scraping process itself?
Sure. What would you like to hear about?
I guess it's not a public API of Miles, right? So. Or maybe I'm wrong.
Well, kind of every API is public. Some have authorization, some don't. Some have rate limiting, some don't.
Thanks for this.
Thanks for the talk. Sorry, you might have already explained it, and I'm also not from this sector. I was wondering, how would you measure, like, if this is bringing value to the business, and if any of those platform users could maybe use this to implement, or maybe they're already having something similar internally? Yeah, thanks for that.
You did listen closely. I did not talk about this so far. What's usually being done is you just start using it in a on a small scale in the system once you're confident that your system works. And with these numbers, I'm not confident the system works. And then you look at the idle time of each vehicle. So in this case, the vehicle after it's been driven to the location where it's supposed to go compared to just any random vehicle. Is it lower than you would expect or not?
Next one.
Yeah, great talk, thank you. I also worked a little bit during my bachelor and master thesis with location-based services. I guess you could add infinited additional data sources like where restaurants, where some opening, where Taylor Swift concerts take place. Have you considered this?
I did. And in fact, I wrote my bachelor thesis on this topic. In a few days, I'm going to publish it here. And so it's much easier to predict long-term demand than short-term demand. And for short-term demand, I was missing exactly those sources you're mentioning. Are there any restaurant openings? Are there major events in Columbia Hallo or something? And those are obviously really useful. The only live data I had was traffic and weather, because I was interested in seeing if there is an impact and there is not. But obviously for other data, I think those are massively important.
Yes, coming.
Another idea I just had was if you can somehow scrape the API from BVG and correlate when the S-Bahn is not working and if these car rentals go up.
I love that, yeah.
Another question? Yes. Okay. Trying to make me run, that's crazy.
Yeah, thank you. The question about how you estimated the idle time. Did you have a vehicle ID in your data set?
Yep.
Okay.
And I mean, it makes sense that this is public because if you see the vehicle in your app as a user, you want to at least know the license plate, right? To identify the car.
I'm in the middle, so it should be from one of the extreme. I don't know.
Yeah, thanks a lot. Very nice talk. I have a question. In the maps that you showed with the color coding, was this the end of the trip or the beginning of the trip?
So are you talking about this?
No, a few slides before. Yeah, so with the
Yes.
things with the mornings and so on, yes?
This is the start of trips.
Start of the trip, okay.
Yes. I also did the same kind of thing for the end, but didn't show it here.
It's just the investing or similar. Okay, and then one other question that I have is, so the thing, if you would have personal identifying data, you could do dynamical pricing for people basically to suggest them to take a ride because you somehow can guess where they're going or what?
Yes, that's the idea.
Okay, thanks. Did you sell the idea already to Miles?
No.
Did you consider taking a multi-step approach, something like maybe first estimating the total amount of the trip and then estimating the location and the destination?
So what you're saying is include the price of the potential trip in your estimation of if it's a likely trip or not?
No, first for how long the car was hired, and then what the destination actually was.
So how long was the trip? Yeah, just including how long the trip was.
Yeah.
Right. Okay. I did limit the vehicles to 12 hours maximum rides, and I do also have intermediate points between start and end locations, so I made sure not to include round trips. But apart from this, I didn't account for the time, no. But if you're trying to predict where people are going, obviously you don't know how long that trip is going to be in the future, right?
Thank you for the talk. And just a question, did you compare this publicly available data set for starting and end of the trip to the car sharing? Is there a difference on the pattern of usage between the people that use car sharing or, next bike or public transport?
No, I didn't, but a friend of mine is doing a very similar thing on Nextbike. So I think once he's done, we're going to share our results, and it'll be exciting.
Thank you. did you explore or think about the same use case but for parking? So to predict the parking situation, because that would be maybe a less cheap way to get people to the less frequented areas. I mean, parking is super annoying for most users in Berlin, at least, and big cities. And I guess there's a high correlation between the areas where people always, where all the cars go, and the parking situation there.
Yeah, actually, for example, in Milano, I don't know, is that the English word? Parking availability is one of the primary factors influencing car sharing use. So people go less to areas where it's difficult to find parking spots, which makes sense. I haven't heard such a thing about Berlin, and I haven't identified it because I didn't look into parking availability, but that would definitely be an interesting factor to accommodate. So many great additional factors here.
Okay, other questions? I think you have enough work for the next year. So.
All right.
Yeah, thank you.